Okay, so these are the answers for page 46 that I assigned yesterday. And I think question 1 was you were supposed to find the speed and the displacement at 2 seconds, right? So at 2 seconds, you just read it right off the graph. It's equal to 10. The displacement, it's triangle plus rectangle, right? Because if you look carefully, and I really should have the actual, I think it's like this, right?
Yeah.
So you're talking about triangle plus rectangle. So 1/2, 2 times 10 plus 2 times 10, or 30. T is equal to 7 seconds. The speed is 15. Notice that it's the speed. If it asks for velocity, technically it would be minus 15. They're kind of messing with you a little bit here. I would say that the distance traveled is 62.5, but I think if I'm not mistaken, the question actually says, they just word it really poor, don't they? The question says the distance from where he started. The distance from where he started, that kind of implies displacement, which means that one of these values is supposed to be negative. Is it the 22.5? Is that the one that's below?
Yeah, it's negative.
Okay, so this one maybe should be negative, which would mean that your answer is different. But when they say distance from, they're being a little vague. That's properly called displacement. So it's a poorly worded question. Quite often I get problems if people get it wrong. Okay, so now if we move on to number 2, if it's a uniform motion forward, well, that is flat. If it's uniform motion backward, that's also flat, but in the negative area. If it's speeding up forward, velocity time graph, increasing line, straight increasing line. If it's speeding up backward, that's going to be a straight decreasing line, like so. I think I have 2 D's here for some reason. Slowing down forward is like that because the velocity is going towards 0. And it's forward because it's positive. And E is slowing down backward. So notice that both of these are slowing down. How can you see something slowing down from a velocity time graph? It goes towards 0. Exactly. That's the key there. It goes towards 0. It says for the graph, this is number 3 now, for the graphs in question 2, produce simple scales ranging from 0 to 5 and 0 to 5. In other words, make everything 5. Like this is 0, that's 5, that's 5. Just do that for everything. That's what they're saying. Okay, so put 5s everywhere like I just did. And then you go and you find the acceleration. So the acceleration here for A, acceleration is flat, so the slope is flat, so it's 0. The displacement is 25 because the area is 25, and the average velocity is 5. It's actually a constant 5, isn't it? In B, acceleration once again is 0. It's flat. The displacement is minus 25. It's below. And the average velocity is minus 5. It's a constant minus 5. In C, I have a slope of 1, 5 over 5. The displacement is 1/2 5 times 5, or 12.5. And the average velocity, and Mike had this right here, you have to take the displacement divided by the time to get that average velocity of 2 points. Actually, 2.55, isn't it? Or is that a typo? Is this 2.5? Must be a typo? My apologies.
Never forgive you.
Yeah, sorry about that. Okay, let's go on to the next 3. Here, the the acceleration is minus 1, minus 5, or minus 5. The displacement is minus 12.5 because it's the area of this triangle here, right? Area of this triangle. And the average velocity minus 2.5 divided by 5. Notice here the acceleration is the same, minus 1. These ones are the same. This one is slowing down, this one's speeding up. But the acceleration is the same. Very odd. The acceleration is both minus 1 here and minus 1 here. This one's speeding up, this one's slowing down. Displacement 12.5. We're talking about that area there. Average velocity 12.5 divided by 5. I think the rest is sort of self-explanatory. Now number 4 is also a spot where traditionally we have a bit of a stumbling block. So let's have a look at number 4. Number 4 says that you are to create, from the DT graph in figure 118, generate a corresponding VT graph. Make a velocity time graph. This is the displacement time graph. Take the tangents that it's been provided, find the slopes. The slope here at A is 0. The slope here at B is 12. The slope here at C is about 31. Okay, how did I do that? By finding tangent lines and doing slopes. Then what do I do to these velocity figures to create the velocity time graph? Just graph them. Just graph them. Graph 0, 0, 1.5, and 12, and 3.5, and 3.1. And you actually get a graph that looks like that. Is that a straight line?
No.
It's not. It's not actually a straight line, which now you could argue, well, it's pretty close to straight. Are these slopes perfect here? No, probably not, right? Would more than 3 points give you a better version? Probably, right? It's probably supposed to be straight. The only reason that it's not straight is because these are tangents, and I'm thinking 3.5 and 31, that's maybe not exact kind of thing. Well, I mean, I probably wouldn't ask you to do that. If I did, I'd say you have to come up with 5 points or something, right? And I wouldn't expect it to do perfectly straight either. If this isn't perfectly straight, what does that actually mean? It means that the acceleration is changing. It's actually constant there, and then it changes there. There's an increase in acceleration there. Perhaps. Okay. So I'll just leave that for now. You guys can go ahead if you want to work. I'm not going to go on with anything new with these guys being away. If you want to go to page 69 and work on those graphs there, please remember that I've given you the photocopies to work on. Use those.
Can you